Introduction of Green's Theorem. Green's theorem was named after George Green after his influential works of an essay on the application of mathematical analysis to the theories of electricity and magnetism in 1828. For a continuously differentiable two-dimensional vector field fxy and a piecewise modes, simple closed curve C oriented positively and bounding a region R, Green's theorem states integration of f multiplied by dr equal to double integration of partial derivative p over partial derivative x plus partial derivative q over partial derivative y, where p and q are the components of fxy and dA is the area element. This consist equation encapsulates the essence of Green's theorem, enabling us to translate line integrals of f around C into double integrals over R involving the diversion of f.
Question for case study 1. Use Green theorem to evaluate the integrate of FDR where C is a curve formed by a parabola and line as shown in this figure 1. The figure shows that the straight line is y equal to 4 and the curve is y equal to x squared. Okay, now we move to manual calculation for case study 1. First, we let P equal to 3y plus e power of x ln y plus 1 and we let Q equal to 5x plus e power of x over y plus 1 and then we differentiate P respect to y, we get 3 plus e power of x over y plus 1 and we differentiate Q respect to x, we get 5 plus e power of x over y plus 1 and then we double integrate dq over dx minus dp over dy dA. And then we get 5 plus e power of x over y plus 1 minus 3 plus e power of x over y plus 1 dA. And then we get the double integral of 2 dy dx from x squared to 4 and negative 2 to 2. After we solve the equation, we get the answer is 64 over 3.
For the Maple Common case study 1, we will start with the common restart with linear algebra. And then we will insert equation P 3y plus exponent to the power of x ln y plus 1. And then Q equal to 5x plus exponent to the power of x over y plus 1. And then we will insert the differentiate P to the respect y and then differentiate Q to the respect x. And then we will insert the boundary from x squared to 4 for boundary y, and for boundary x is from negative 2 to 2. Then we insert the 2 dy dx. And we integrate to the respect of dy dx and we will get 64 over 3. And next we will do f equal to map in bracket 3y plus exponent x ln y plus 1 and 5x plus exponent to the power of x over y plus 1. And R1 is t4, for R2 is t squared. And finally, we'll insert command for plot the graph as follow, and we will get the graph as in the picture.
For case study number 2, the question is use Green theorem to evaluate integrate x power of 3 minus xy dx plus 6y minus 9x dy, where c is indicated in the figure below. For the manual calculation for case study number 2, I have stated the main formula that we need to use, and we put out the p, which is x power of 3 minus xy, and we differentiate it respect to y, and the answer is negative x. Next, we put out the q, which is 6y minus 9x, and we differentiate respect to x, which the answer is negative 9. Next, qx minus py, and the answer is x minus 9. Then we integrate it respect to dy dx. So first integration with respect to dy, which the answer is x bracket x minus 9 times bracket 1 over 2x plus 2x. Next, we want to simplify it, and we get 5 over 2x square minus 45 over 2x, and we differentiate its respect to dx, and the answer 5 over 3x or power of 3 minus 45 over 2x squared, and we integrate it, and the answer is 320 over 3 minus 360, and the answer for the minus we times with negative 1 over 2, and the final answer is 380 over 3. Thank you.
Alright, now for the maple coding, first we need to restart with linear algebra, and then we want to declare variable p, which is x with the power of 3 minus xy, and then q is 6y minus 9x, and then we want to differentiate p with respect to y, and you will get negative x. Meanwhile, where you differentiate q with respect of x, you will get negative 9. And then we want to set the boundary limit of y, which is negative 2x is less than or equal to y, or is less than x over 2. And then you want to set the boundary limit of x, which is 0 is less than or equal to x, or is less than or equal to 4. And then you want to set the integration, which is x negative 9 dy dx, integrate negative 2x to x over 2, and then we'll integrate 0 over 4, 0 to 4. We put the negative sign because this question curve is moving in a clockwise manner, not anti-clockwise. The theorem says that we want to integrate between the curve and the surfaces in a anti-clockwise manner. Okay, next for the f, we want to put map with the bracket unapplied, and then you will put the equation of the vector value function of the question, and then for the r1, r2 and r3, you will get them by finding their parametric equation of each line. And then lastly, for the plotting, you will plot by using try and error method, and you will get the graph like this.